In section 4.2, we're going to work more with the graphs of these rational equations. But it's kind of more in a kind of a standard form rather than the form that was set up for finding them very nicely. So we're going to talk about how do we find our vertical asymptotes and how do we find our horizontal asymptotes. The vertical asymptotes are pretty easy. We basically just set our denominator equal to 0 and then solve it. Okay, so we'll do an example here. So we set, for our vertical asymptote, we just set this 2x squared plus 5x minus 3. We set that equal to 0 and solve it. Okay, so thinking about how we solved it last chapter, I'm going to choose factoring here. You can use quadratic formula, completing the square, whichever method you want. So I'm going to make this a plus 3 and a minus 1. That'd be 6 minus 1 is 5. Okay, solving it gives me x equals 1/2 and x equals negative 3. Okay, now let's think about why these things why this is where our asymptotes are. So if I put a negative 3 in here, negative 3 squared is 9 times 2 is 18. 18 minus 15 minus 3 is equal to 0. Now, can I take something and divide by 0? No. Same with 1/2. Can I take, if I plug it in here, I get 0. Can I take anything divided by 0? No. So I know that at negative 3 I have an asymptote, and at 1/2 I have an asymptote. Okay? Those are my vertical asymptotes. Okay, now my horizontal asymptotes are a little bit tougher. So I have to look at the degree, the exponent of the highest degree. Okay? So if they're both equal, like degree 1 and degree 1, I'm going to take the numbers in front, and that'll be where my line is. Okay? So if I have like, 3x squared blah 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 and 4x squared blah blah blah, my horizontal would be at y is equal to 3/4. Okay? So if they're equal, you take the numbers in front. Okay? Now, if the denominator is a higher degree than the numerator, then it's always going to be at y equals 0. And if it's a higher degree on the top than the bottom, then it's not going to have a horizontal asymptote, but it's going to have an oblique asymptote or a slant asymptote, which is going to be an equation of a line. Okay? And the way we find that is we divide and we ignore the remainder. Okay? So we'll get to an example with that in a little bit. So with number 1 here, we'll complete this. Okay, so number 1 here, so we have our vertical ones. Now our horizontal asymptotes. Horizontal, notice it's bigger on the bottom. So if it's bigger on the bottom, it's going to be at y equals 0. So we have a horizontal asymptote at 0 here. Okay, now also want to find the x-intercepts. X-intercept was when my y is equal to 0. So if I set this equation, okay, if I solve this equation, 0 is the same as 0 over 1. So if I cross multiply, 0 times this is 0, and that times that is x plus 1. So if I solve that, I get x equals negative 1. So I know it's going to have an x-intercept right here at negative 1. It's going to cross through here. Y-intercept happens when my x is a 0. So my y is going to equal 0 plus 1 over 2 times 0 squared plus 5 times 0 minus 3. So basically that's at y is equal to 1 over negative 3. So I know at negative 1/3 is going to go through the y. Okay? Now for the rest of it, and you can also verify it by looking at Desmos. Okay? But to get the general graph, let's go to Desmos and graph it. Okay? From the Desmos graph, you can see that in the middle here it comes down and through like this. Okay? It also looks like this over here, and it looks like this over here. Okay, so there we have our graph. We have our x-intercept, y-intercept, and all of our asymptotes we're looking for there. Okay, and that's when they ask for a comprehensive graph. That's what they're looking for: the x-intercepts, the y-intercepts, all the asymptotes, and the end behavior. Okay, so looking at end behavior there as well. Okay, let's try another one. Okay, so vertical asymptote. Remember vertical asymptote, we just set the denominator equal to 0. So I have 3 here, right? 3 minus 3 would be 0. I can't divide by 0. That's why there is an asymptote at 3. Okay, horizontal asymptote. They're both x to the first, right? So if they're both equal, we're going to do with just a over b. So just 2 over 1. Okay, so I have my two asymptotes. My x-intercept happens when my y is a 0. Okay, if I cross multiply, 0 times x minus 3 is 0. And if I solve this, I get negative 1/2. So I know it's going to intercept my x-axis at negative 1/2. My y-intercept happens when I plug 0 in for the x's. So 2 times 0 plus 1 over 0 minus 3 gives me negative 1/3. It's interesting, it's the same as up there. Anyway, it's not always going to be that, but so negative 1/3. Okay, try and take a guess at what that looks like before you graph it on Desmos. Okay, so it goes through like this and like this. Okay, try another one, number 3. At any time, pause these and do them yourself a little bit. So vertical asymptote, when you set the bottom equal to 0. So I know at 2. And the horizontal asymptote, okay, it's bigger on the top. So bigger on the top means we're going to have to, there's no horizontal. So it has no horizontal asymptote. But let's actually find that that oblique or the slant one. So we're going to do that by dividing. Actually, you can use long division, but I'm going to use synthetic actually. So 2, and then 1x second, 0 x's, and 1. Okay, so don't forget that 0 in there. Okay, so the way this answer would be, it'd be x squared plus, I'm sorry, not x squared, it'd just be x. X plus 2 plus a remainder of 5 over x minus 2. Okay, so the way we get our slant is we ignore the remainder part and we just look at this part right here. Okay, so if I think about x plus 2, okay, that's a line where I start at 2 and I go up 1 and over 1, right? So that is an asymptote as well. We haven't talked about slant asymptotes yet, but that's our slant asymptote. So it's going to get closer and closer to that, but never actually touch it. Okay. Okay. X-intercept once again happens when our y is a 0. Okay. So if I just cross multiply, I have x squared plus 1 equals 0. Subtract the 1 over, I get x equal plus or minus I. So that kind of tells us that there is no real x-intercept, right? It's not really going to cross here. Okay? And then the y-intercept, 0 squared plus 1 over 0 minus 2 gives me negative 1/2. So I know, okay, so if I look at this graph, it's going to cross at negative 1/2 right there. And it's not going to intercept my x-axis at all. Okay? Now, if you go to Desmos and get a graph of this, the graph will look something like this. Okay, so it doesn't cross the x-axis there, and we have it getting closer and closer to these, but not crossing. So that's an example with a slant. Okay, let's try another one. Okay, vertical asymptote, set the bottom equal to 0. And that gives me an x equals negative 4. So I know that x does not work right there. Okay, for the horizontal asymptote, they're equal. So remember, if they're equal, we take the number in front. So it's at y is equal to 3 over 1. X x-intercept happens when my y is a 0 here. So basically when this is equal to 0, I'm going to factor out a 3. And this would be x minus 2 and x plus 1. Okay, so x equals 2 and negative 1. So my x-intercepts happen at 2 and at negative 1. Okay, y-intercept happens when my x is a 0, so I put zeros in here everywhere. I have negative 6 over 16, which would be what? Negative 3 over 8. So y-intercept, down around there somewhere. Okay, now to get our graph, go to Desmos. Okay, so this one looks like this in this area. This one's a little different though, okay, because it crosses here. That's a little bit unusual. We haven't seen that yet, but it does cross in this particular one. And it comes down through here, and then back up through here, and then it approaches the asymptote down here, and it gets closer and closer there. Okay, that's number 4. Number 5. Now there's not always going to be an asymptote, it might also just be a point in discontinuity. Okay, and we'll see why here of this. Usually to find our vertical asymptote we set this equal to 0 here, right? And we get x equals 2. But let's see what happens here. If I take the top and I factor it, be x plus 2 and x minus 2 over x minus 2. Notice what happens here if I was going to simplify this. Notice those cancel and I just have x plus 2, right? Okay. So really when you're graphing this, we just have the equation x plus 2. So you start at 2, go up 1 over 1, right? So we have this line. But what happens here at 2, okay, at 2 here, this is going to be an open circle there because I can't have it equal to 2. If I put a 2 in here, 2 minus 2 is 0. I can't divide by 0. That's why there's there. So instead of an asymptote, when the factors cross out like that, it just makes an open hole. Okay, so it's called a point of discontinuity, right? I come in here and I have to jump over that to get to there. Okay. Now there's also sometimes when there's no vertical asymptotes. If I set the bottom equal to 0 here, I get x squared equals negative 1, so x equals plus or minus I, right? So there's no vertical asymptotes here. There is a horizontal though. Remember x squared on the bottom, so it's at 0. So, and you can go and find your x-intercepts and y-intercepts and so forth. There are no x-intercepts here, but the y-intercept is at 1. So you can, the graph, if you look at the graph, will look something like this. Okay, and the very last one here, we'll do one more. Looks complicated, doesn't it? Okay, so vertical asymptote. Remember we set the bottom equal to 0. So when I set that equal to 0, it doesn't solve, it doesn't factor. So if I try to use the quadratic formula, there's imaginary solutions. So there really are no vertical asymptotes to it. There's no number, no real number that I can put in here for these x's for it to be equal to 0. The horizontal, notice it's bigger on the top than the bottom, bigger degree. So when there's a bigger degree on the top than the bottom, we know there's no horizontal, but there might be an oblique, so we have to divide it. So if you divide it, okay, so I'm going to be what, 2x? So 2x times this. And draw the line, change the sign to subtract. Gives you what would be x squared minus 4x plus 1, then plus 1, x squared minus x plus 1, change the sign, comes up with negative 3x, that'll cancel out. So negative 3x over that, but we ignore that, so we know our oblique will be at 2x plus 1. So remember, add plus 1, go up 2 over 1. Okay, so we have an oblique or slant asymptote right here. Okay, the x-intercept is where I set the y equal to 0. Basically is this. Okay, so factor out an x squared, 2x minus 1, take out a negative 1, and I get 2x minus 1 using the grouping method. So it'll be x squared minus 1 and 2x minus 1. So I'll have it at 1/2 and at 1 and at negative 1. Okay, so 1/2 at 1 and negative 1. Y-intercept is when my x is 0, so put x as 0 in here, I get 1 over 1. So y equals 1 right there. Okay, so when you graph this then, it'll look something like this. Okay, so the end behavior follows the slanted asymptote, and we have all those intercepts and stuff in there. Okay.